We're talking about point slope form. It is y minus y1 equals the slope times x minus x1. Here we go. Write an equation in point slope form of the line that passes through the point 3, 5. Okay, now I know you're doing this online, but something I recommend, if you plan on memorizing this formula, which might be a good idea, is to write it. I know that sounds crazy, but here's what I recommend. You write exactly what I've written right here. This is the original formula. And then this one right here is everything that does not change when you plug in information. So what information are you going to plug in? Well, here's the point. That's the x, positive 3. There's the y, positive 5, and has a slope of negative 1 right there. And then, as I told you in class, the nice thing about this is if you're ever asked to write an equation in point slope form, we're done. So, and here's the other funny part about this multiple choice math is all I had to do was look for y minus 5, because that one doesn't have y minus 5, that one doesn't have y minus 5, that one doesn't have y minus 5. So that was the only possible answer. Moving on. Y minus y1 equals m times x minus x1. I'm not going to write this every time because I don't need to have memorized this. You're the one who would be a good idea for you to memorize it. But again, here's what I'm going to do. I'm plugging in my x, negative 8. Plugging in my y, negative 2. My slope is 5. And then if you were going to look over here for y minus negative 2, you're not going to find it because this is y plus 2. These two negatives make a positive, and this is going to be x plus 8. There it is. It's B. I can't guarantee that your answer choice is B, by the way, but it is that one for me. Write an equation in point slope form. Y minus negative 1/2. Why did I write down y minus negative 1/2 immediately? Because that's my y, and this is the left side of the formula, which is y minus y1, right? And the right side of the formula is the slope times x minus 0, that's my x. And because the right side of the formula is m times x minus x1. Okay, now if you take a look at the answer choices, the left side should be y plus 1/2. It's this one. Now, just for fun, look at the right side. It's just 3/4 x. Wait a second. Why do we have that written down? Well, that really is just 3/4 x, right? We don't need to write 3/4 x minus 0. Why would we do that? Oh, it's starting to look more complicated, but not really. Y minus 8.2 equals 1.5x minus negative 6. Now, I wrote minus negative 6, but you're going to get to a point where you can just look at this and understand that it's just going to be that plus 6 right there, okay? So looking at our answer choices, it's got to be that one. Write an equation in slope-intercept form of the line shown. Well, if you notice, they did not give us a y-intercept. We are very much used to doing slope-intercept form where you have the slope and the y-intercept, but we weren't given one of those. You could pretty much guess what it is. I mean, because that pretty much looks right, like right there, and if we were to count that real quick, here's negative 1, negative 2, negative 3, negative 4. So I'm pretty sure, since I'm going for slope-intercept form, it's going to be y equals mx minus 4, and then now I need to find the slope. So, like, there's a dot, nope, sorry, that was a dot I did, right? It's blue, so I just need to erase to make sure. Yeah, it's blue, that was my dot. Okay, there we go. So I'm going to rise 1, 2, 3, 4, 5 in the negative direction and run 1, 2, 3, 4, 5 in the positive direction. That's negative 5 over 5. And that is negative 1. So y equals negative x minus 4. Now, we were really sure that this is negative 4, right? But if we wanted to be like a million bajillion percent sure, we would plug this point in. And I just want to do that real quick. So y equals negative x minus 4. We're going to plug in 1, negative 5. So our x is 1, our y is negative 5. Negative 5 equals negative 1 minus 4. And oh, look, negative 5 equals negative 5. So according to this point and this slope, we're good. So final answer, right there. Write an equation in slope-intercept form of this one, okay? Again, we're going to kind of cheat and just go, hey, look, it looks like it's right there. This graph is counting by 2's, so this is what I think we have right away, okay? And now I'm going to plug in, sorry, I was about to say I'm going to plug in. You know what? I'm going to do that. I'm going to pretend like I can't count the slope here, like as if I didn't have these points. I'm going to plug in 4, 1. 4, 1, that's x, that's y. So 1 equals m times 4 minus 2. You might think this is a little strange, in which case, if you think it's strange, then just skip to the part where I do it the other way. But look, 1 equals 4m minus 2. Add 2 to get 3. And I can solve for m by dividing by 4. M is 3/4. So what I just did is I used the slope-intercept form. I used the y-intercept and another point to find the slope. And if you're like, well, that seems weird. Not really. You can find the slope from 2 points. The y-intercept is a point, and a point is a point, right? So anyway, we think it's 3/4. Let's zoom in and find out. This is at x is 4 and y is 1, right? So we're going to go up 1, 2, 3. We went up 3. So we just went up y is 3, and we're going to run over 2, 4. Well, check it out. That's what we got, 3/4. So final answer for this equation, y equals 3/4 x minus 2. Let's go. And by the way, if you're like, wait a second, we haven't been doing the point slope form since like earlier. You're right. Oh, well, you know, sometimes they're going to mix things up, right? Anyway, write an equation in slope-intercept form of a line that passes through that. Okay, now we're kind of getting into, they're leading you down the path of, why don't you find the equation of a line without the y-intercept? So here we go. We need the slope. y2 minus y1 over x2 minus x1. Y plus 2 equals, or over 6. 3/6. Our slope is 1/2, yeah? Now here's the part where I just kind of did this. I said, hey, you know what? What if we had y equals 1/2 x plus b? How is that like what we just did? Well, up here, I said, hey, what if we had y equals mx minus 2? So if you're a little confused, this was the unknown we were solving for here. This is the unknown we're solving for here, okay? So let's do that. Which point should we use? The answer is either one of them. So why not 12? That's x and y. So 1 equals, and in fact, I'll try and keep it the same colors so you kind of see what the heck I'm doing. Our y was 1, our x was 12. The 1/2 and the b were just part of the equation that we were using with slope-intercept form. So now 1/2 times 12, that's 6. 1 equals 6 plus b. Subtract 6, and we get b is negative 5. So does that work? Yes. The equation of this line is 1/2 x minus 5. Okay? Now, if you're thinking, well, wait a second, that says find slope-intercept form, and we've been talking about point slope form. Couldn't we, or maybe even shouldn't we have done point slope form? You know what? Let's do that. Let's do that right now. y minus y1 equals, well, we had our slope. We found it. Like that, right? Which point do you want to use? Well, you know what? We just used 12, 1. Let's get crazy. Let's use 6, negative 2 now. So 6, negative 2, that's the x, that's the y. Let's zoom in here and do this thing. Y minus negative 2 equals 1/2 times x minus 6. That's in point slope form. We want slope intercept form. And one thing I told you in our previous assignment is to do this, you just get y by itself. We just want to solve for y, okay? So in order to do that, we got to simplify this. Y plus 2 equals 1/2 x minus 3. And it's not that crazy. In order to get y by itself, we're just going to subtract 2 from both sides. Y equals 1/2 x minus 5. Hold up. Wait a minute. Isn't that what we got right here? It sure is. So now you've seen two different ways that we could write an equation in slope-intercept form of a line that passes through two different points. Yay. Write an equation in slope-intercept form of a line that passes through those 2 points. We're going to do it like 5 more times. Okay? Okay. So let's jump in here. X, y, 13 minus 19. By the way, why did I do this? It's a habit. It's something that I got used to because I would confuse sometimes, like, oh, I'd be like, okay, that minus that, and that wasn't right. You know what I mean? So anyway, y minus y1, y2 minus y1 over x minus x2. This is negative 6 over 10. That's negative 3/5. That's our slope. And let's do y minus, which point do you want to pick? I'll pick that one because it doesn't have negatives, and I just don't feel like dealing with negatives. Y minus 13 equals negative 3/5 x minus 5. Oh boy. Y minus 13 equals negative 3/5 x plus 3. Oh hey, it didn't end up being as bad as I was thinking it might be. Negative 3/5 x plus 16. There it is. And if you're having trouble seeing that, that is y equals negative 3/5 x plus 16. Write an equation in slope-intercept form. Well, first, slope. We have 1/8 minus negative 3 over negative 1/2 minus 2. Hey, what's up with these fractions, man? All right, well, let me jump out here. 1/8 plus 3. Well, I guess that's not that bad. That's 3 1/8 over negative 2 1/2. Well, if you are rusty on dividing by fractions, one thing I do is I'm not about to mess with mixed numbers like this. I'm going to convert them to improper fractions. So this becomes 25/8. If you're not sure how that happened, 8 times 3 is 24. 24 plus 1 is 25, and 25/8 because it's still eighths. This one is about to become 2 times 2 is 4. 4 plus 1 is 5/2. And it is negative. We are still dividing. And then here's the thing that some of you might remember about dividing fractions is that you flip the second fraction and then you multiply. Controversy is, do you call it keep change flip? Do you call it keep flip change? Do you call it KFC? Or do you just know that you flip the second one, also known as a reciprocal, right? Multiplying straight across. Some of you might be a little bit more professional at multiplying fractions, and you actually know that you can kind of what I call cross cancel. So, I mean, I could show you that, but basically what you get is 50 over 40, and that's pretty simple enough to deal with. You divide them both by 10, you get negative 5/4, right? So, boom, there's our slope. Negative 5/4. How many of you were expecting that? to turn into that. I don't know if I was. Anyway, so our slope, negative 5/4. I got to tell you, I'm planning on using that as the point that I'm going to plug in, just because that seems like it will be a little annoying. So y minus y1 equals negative 5/4 times x minus x1. Since they want it in slope-intercept form, let's simplify. Y plus 3 equals negative 5/4 x plus 10/4. And if you're like, wait, that can be reduced. Yeah, I'm just not going to do it right now. I'm going to subtract 3, which is 12/4, by the way. So y equals negative 5/4 x. And if I subtract 12/4, because remember 3 is really 12/4, right? If I multiply it by 4 over 4. And why am I doing that? Because I have a 4 as my denominator right there. 10/4 minus 12/4 is negative 2/4, also known as y equals negative 5/4 x minus 1/2. Fun stuff, right? That's the answer for this one. Next, write a linear function. Oh no. Just like one we did in class where you guys were like, hey, what the heck is with this? This is just like coded information. Our x here is 5 because this normally is f of x. And f of x is really code for like y equals. So our y is 7. Our y is 7 when x is 5, is what that's saying. And then right here, our x is negative 2 when our y is 0. And don't get this mixed up. This is not a y-intercept. That's an x-intercept. We get an x-intercept when our y is 0. And that does not help us to write in slope-intercept form, which, by the way, there's another bit of a coded message here. They say write a linear function. Do you know what this is? This is like saying y equals. We're basically doing this again. Okay? Okay. Not basically. We are doing that again. But we got to find the slope first. Y, the slope, equals 7 minus 0 over 5 minus negative 2. That's 7 over 7 is 1. Our slope is 1. Y minus, you know what, I like this one because I like messing with 0. Y minus 0 equals, m is 1, so I'm not even going to write anything. I mean, okay, sure, 1 x minus negative 2. We're done. This is it. Y equals x plus 2, or f of x equals x plus 2. That's it. Done. We've got this coded information again. X is negative 10. Y is 4.5. X is negative 2. Y is 4.5. Find the slope. 4.5 minus 4.5. We're about to get 0 on top. And the only reason I'm going to keep going is because if I get a 0 on bottom, which I'm not going to, then it would be undefined. And you know why I'm not going to get a 0 on bottom? Because those x's are two different numbers. So really, it's just 0 over I don't care. My slope is 0, okay? So here's the fun part about this. For point slope form, it's y minus y1 equals 0 times x minus x1. Well, 0 times anything is 0. So really, this is just y minus y1 equals 0. Do you know what this is? It's just y equals 4.5. Do you know how I know that? Because it is. If I plug in my y's, they're both 4.5. And then I'm going to add 4.5 to the other side. And the simple answer is it's f of x equals 4.5. That's it. Write a linear function. Okay. X is negative 9. Y is 10. X is negative 1. Y is negative 2. 10 minus negative 2 over negative 9 minus 1. That's 12 over negative 8, right? Yeah. This is, if I divide by 4, we get 3 over negative 2. If you want to make this a decimal, I'm not mad at that because it's 1.5, right? So that's our slope either way. Y minus 10, why not, equals negative 1.5 times x minus negative 9. Y minus 10 equals negative 1.5x. Okay, now I figured out why not, because I really don't want to do 9 times 1.5 in my head. Let's see. 1 times 9 is 9, and half of 9 is 4.5. That is negative 13.5. Fun. Add the 10. So I wonder if you were to type that in, if it would be happy with that, or if it would say, where's my fractions? So here's the fractions. Let's see, 3.5, 3 1/2, that's 7 halves. So there's the fractions in case they're looking for them. Tell me, are you a linear equation? Well, I don't know. X is going up by 1, by 1, by 1, by, I'm sorry. I knew one of them went up by 2. I just said the wrong one, by 2, by 1. So hang on, are we mad at that? That it didn't go up by a constant? Not yet, okay? Let's check these guys first and find the slope, right? Because it's possible that you have a drawing like this. Here's our line. And then imagine I said, hey, this goes up 1 over 1. And then imagine I said, then it goes up 2 over 2. Well, that's still a constant rate because it's like going up 1 over 1 twice, right? So we can go a distance of 2. It would still be constant, right? So anyway, let's check this out. y2 minus y1 over x2 minus x1, okay? Well, so what's happening is we get 0.2 over 1, so our slope is 0.2. Or I guess we could leave it like this so this is the change in y over the change in x. So as y goes up by 0.2, x increases by 1, okay? So then if x were to increase by 2, this would need to go up by 0.4, and oh my goodness, it does, right? So each one of these, that goes up by 0.2, that goes up by 0.2, as we already said, that goes up by 0.4, and this goes up by 0.2. So, heck yes, this is a linear equation. The data blank the model to be a linear. Okay, yes, I think it's like confirms or whatever. So now it says, let's write an equation to represent that function. Well, that's really easy. Now that we've kind of done the math, our slope is 0.2. So really, if we just go look, I mean, it's that one. It's 0.2x. That's our slope. But then also, here's our y-intercept of 1.2. When x is 0, you get the y-intercept. So, boom, there's our y-intercept of 1.2. Modeling in real life, you want to order posters to advertise your band. A company charges $109.95 for the first 100 posters and $65 for each additional 100 posters. Write the equation that represents the total cost y in dollars as a function of the number in hundreds of posters ordered. Okay, so y equals mx plus b. X represents hundreds of posters, okay? And we are charged $109.95 for the first 100 posters and $65 for each additional 100 posters. So my thought process is it is y equals 65x plus 109.95. Why? This is what we get charged no matter what. I mean, because I guess we're assuming that the band is going to be ordering a bunch of posters, right? I mean, if you're going to advertise, why not? Why stop at 100, right? There's 100, and then this is what it costs for each additional 100. So boom, this is your answer right here. And then it says find the total cost of 1,000 posters, which means you're going to plug in 10. Why 10? Because if this is in hundreds, it only takes 10 hundreds to reach 1,000. So we can kind of do this math almost in our head. 10 times 65 is 650 plus 109.95. That's 759.95. Let me write that a little more clearly. 759.95. That's the cost. Describe and correct the error in writing an equation of a line that passes through the points 1, 2, and 4, 3. Okay, so let's zoom in here. We got x, y, x, y. So y2 minus y1. Hang on, let me change the pointer. y2 minus y1, that's good. And x2 minus x1, that's good. 3 minus 2 is 1. 4 minus 1 is 3. I like it. That's our slope. Put it right there. Y minus 2 equals 1/3 x minus, oops. So that's wrong. If we use 2, then we need to be using 1 right here. That is our mistake. Making an argument, your friend says she can write a linear function g with the values that and that. Is your friend correct? So if you're like, what the heck am I even answering here? She's saying it's a linear function, and a linear function is a straight line. It would not be a vertical line, right? So let's see if she can do that. So her x here is 4. Her y is -2. Her x here is -1. Her y is -2. Well, I got to tell you, if we were to just draw this real quick, 1, 2, 3, 4, 1, 2. Boom, right there. And then the other one is -1, -2. What do you think? That is a horizontal line. She got it. Now, if you were to explain your reasoning, it's going to be tough for you to, on the computer, say that. Other than you could just say the words like, graph it, it's horizontal. You know what I mean? And by the way, I know that's horrible writing, but you can hear me also. So graph it, it's horizontal. Or you could say, well, of course, I found the slope of these points, and then I, did slope-intercept form, yada, yada, yada. And you'd be right with saying that too. 3 bank accounts are opened and then have fixed amounts of money withdrawn each month. The graph shows account A, the table represents account B, and the equation represents account C. Y represents the amount of money in dollars left after X months. So we got money equals M months plus B. Y equals MX plus B. Y equals MX plus B. Okay. So what are we supposed to do? We are asked which account has the greatest initial value. Ooh, this is a great idea here. That's the y-intercept. Okay? Essentially, the y-intercept is how much do you have when time equals 0. And in our case, when the month equals 0. And you will not always be able to just look and figure that out. For example, here, this was, the table is B, right? So here, I'll throw a B on there. This one was A, and then the equation was C, right? I can look at these two and kind of figure it out. So this one, so C was 90. C, 90. A, 80. Don't believe me? Zoom in. There it is, 80. But this one, we have to kind of figure out the slope. Notice they're going down $25 a month. So if we were to then add, we'd have 125 here at month 0. So B started with 125. So which account has the greatest initial value? B. And then C. Oh, it doesn't even say that. Oh, okay. Sorry, which has the greatest and then the least? So it was B, then A. Gotcha. B, then A. There we go. Which account has the most amount of money withdrawn each month? Okay. So this one is going down. So B. Let's do that again. B is losing 25 a month. This one is losing $22.50 a month. So C, losing $22.50 a month. And if you're like, how did he get that? It's right there. It's the slope. That is the slope per month, right? The money per month, okay? And then this guy, we got to kind of do our math here. After 2 months, so after 2 months, slope is the change in y over the change in x. Rise, which is a y value. Run, which is an x value. We rose 2. We ran 30, right? And you're like, wait, what? 2 months went by. 2 months went by. The y value went from 50 down to 20. That's a difference of 30. So the slope here is $15 a month. So 15 like that. And I guess you could say negative 15, right? So which one has the most amount of money withdrawn? Well, that would be B. And then the least, well, that was A. And notice I wrote M. That's my bad. So it was BA. BA is that one. Which account runs out of money first? Ooh. So B takes 5 months. How do I know? Because it's going down 25 and it was 0 at 5 months. This guy right here, a little over 5 months. So let's call it 5.25. Why not? Because there's half, right? And there's half of half. So, okay, we have B was 5 months. A is 5.25 months. And now C, we actually have to do some math here. Oh no. There's our equation. We find an x-intercept, which if you're like, wait, x-intercept, that's where it intercepts the x-axis. When it will be 0, the x-intercept is when y equals 0. So check this out. We're going to have 0 equals negative 22.5x plus 90. Okay? This is because we plugged in y equals 0 because we want to know what's x. So subtract 90. Negative 22.5x. We're going to divide by 22.5. And we got to do some dividing here. 22.5. Let's see. How many times this would go in? Let's say 4 times exactly. Yeah, I think that's 4 times. 4 times 5 is 20. Carry the 2, that's 8. And carry the 1, 8. Yeah, it's exactly 4. So C is 4 months. All right. Which runs out of money first? C. And then A, which was last. So that was the whole assignment on point-slope form. You might think we did a ton with slope-intercept form, but we had to get there. We started with the point-slope form. All right, let me know what questions you got. See ya.